Okay, even if I don't like geometry, I like this question because I can predict exactly what's going on in this question. I've done a lot of SATs, obviously. When I see that a question involves a circle, and that circle is chopped up in some way, and they care about a part of that circle, I know that I'm going to, in some way, need to use part over whole ratios, right? We can always chop up circles, right? With different slices of pizza, different slices of pie. We're always cutting up circles. It doesn't matter if there's no actual story here. We're still cutting it up, and we can use fractions to represent the pieces of the circle that we care about. So part over whole. What do we ask to care about here? We want the value of x. So that x is part of the circle. It is an angle measure, and the whole number of angles of degrees in a circle is 360. So there we go. We know we want a part, and so we start by comparing that part to the whole. And angles especially are helpful on the SAT because we always know the whole number of degrees in a circle. So it lets us set up a fraction kind of quickly and easily. The other part might throw people off though. The length of arc B is 2/5 of the circumference of the circle. So there's a couple of ways to think about it just to wrap your head around it. The math is going to end up being the same. But what they're really saying is we want to know this part, right? This matches with our x, right? So that BC is 2/5 of the whole way around. So one way to think about it is just to simply set it equal to 2/5 because it's the fraction of the circle that we care about, right? So we care what part of the circle x is, and we know that it's 2/5 of the whole thing. So we could just set it up like that. Another way to think about it is that the part is 2/5 of the whole. And if it's 2/5, what would the whole be? The whole would be 1. So now we do have a part over whole fraction, but because the whole is 1, it just all disappears, and we're back to 2/5. Or, if you really want to, if you're really clever, we could arithmetize here. We could say, okay, I'm never even told what the full circumference is, or what this part is. I just know what the fraction has to be. So what if we made BC 2 and the whole circumference 5? Then BC would be 2/5 because 2 is 2/5, and so sure enough, 2 is the part, 5 is the whole. We made those numbers up, but it all fits. And so no matter what, we are going to end up with a fraction that looks like this. X over 360 is equal to 2 over 5. Questions that have circles chopped into pieces are almost always going to involve a fraction that looks kind of like this. So get used to it. Part over whole fractions. And then what we do is we just cross multiply to solve. So right, x times 5 is 5x. 2 times 360. Maybe we have to do that on the side, but we should get that it is 720. And then we got to divide by 5. And yeah, okay, fine. We got to do some annoying long division maybe, but you should really know how to do that by now, right? 720 divided by 5. 5 goes into 7 once with 2 left over, but short division, I do it here. I put the little 2 here. We can also multiply and subtract, and then we drop down the 2. 5 goes into 22 4 times. 4 times 5 is 20. Subtract, we get another 2. We drop the 0. 5 into 20 4 times, and nothing left over. So there is our answer. X is 144 degrees. It's hard. It's supposed to be hard. It's the last question in the section, and remember the difficulty does reset when we get into the grid-ins, but it's going to go hard as we get through them. But this is also very predictable. We saw in question 18 a point of intersection, and that is also a very predictable thing that the SAT is going to ask you, and they are pretty formulaic about how we solve them. So those are good things to see on the SAT because you should be excited. You know you're going to get that right as long as you're careful. Part of our whole questions come up less often, but it's the same principle. We get back to basics. We know that we're going to end up somehow incorporating this kind of part over whole fraction, and so we use that as our anchor to guide us through the question, no matter how complicated and twisted it gets. And so, because I have more experience, I am excited when I see these because I know exactly what I'm going to do, no matter what that picture looks like. And it's going to involve fractions, and once I've got them, cross multiply and divide, and boom, out pops my answer. It's that easy.